Hi everybody, this is the second video in a series where we look at this workbook Mantle TP Calcs. And in the earlier video we talked about the input in these gray cells here. Again, we're in the CalcP iterative sheet where you input a liquid composition, you assign an FO2. There is another kind of input here that's hidden in the background but that's very important. We're going to slide way over here to the right to column BB. This is the average F, the average melt fraction, as computed from a couple of models. And I think here we're just taking as a default the values from BE and BI, which are a couple of models that I've calibrated. But that doesn't mean they are necessarily the best. They might have negative values or values that are too big or values that are just plain wrong. How would you know? It's not easy to tell. This is probably the single most difficult thing for us to estimate, and it has a very important role in calculating mantle potential temperatures. You can see some of our other videos in terms of looking at the heat of fusion, how we make a correction for a parcel of mantle that is partially melted and corrected up to an adiabat for a solid piece of mantle that is unmelted. At any rate, you might prefer, let's say, Lee and Chin 2014 or Hertzberg and Asimov, and they have a couple of different models that are all shown here. So when you are calculating mantle potential temperature, they will be based on this value here in the average F. And if you don't like that average F and you want to use Lee and Chin, you're going to want to make an edit and then say, grab that cell there, and then of course fill down if you want to apply it to all of your samples, or any other. It doesn't have to be Lee and Chin. You could pick another one of these or one of the Hertzberg and Asimov models. But the key thing is here that before you report a mantle potential temperature, let's go way back over here to column Z and AA. It doesn't matter whether you're in CalcP iterative or input P, they're both set up the same way. You're going to want to slide over here to column BB and check what these average F values are. What is the melt fraction that is being used? And I should probably put in a note here. This is the operative value for the system, for Mantle TP Calcs. This is the value that will be calculated over here when we take the heat of fusion and the heat capacity and turn it into a temperature increase. You can see that we're going to take this ratio here and multiply it by BB, in this case BB8, that's the melt fraction. We're using Cawthorne's calculations to correct for that heat of fusion. This is the temperature increase as we move from the geotherm for a parcel of mantle that is undergoing melting. We're moving an up temperature to the adiabat for an unmelted parcel of mantle. So that temperature increase is going to depend very sensitively to these values here in column BB. So you're going to want to look at those, make sure they're not negative, make sure they're not too high or too crazy. And if you know them, let's say from trace element modeling, you don't need to use any of these models. You can just put in, let's say 20%. Let's say you think it's 20% melting. You can just put in a value and that will have a very significant effect on these values for mantle potential temperature. So be sure to check the estimates for F, degree of partial melting, over in column BB.